Okay, this is a video that is optional to watch. It's meant to help you with the CPM question 6.3.1 number 80. So you can follow the steps that CPM lists. And then this video is basically saying the same thing, but in my words instead of CPM's words. So if it's helpful to have a different explanation, then I hope it's helpful. So here are the two equations. We're trying to solve a system, and we've already just demonstrated that you could use substitution. We could use equal values method, but there's a new method we're learning called the elimination method. And the theory is based on this. Because we have an equation, I'll just take this one on the right here. An equation literally means the left-hand side has the same value as the right-hand side. So 5x minus 3y and 16, even though they don't look the same, they essentially have the same value. Like if we put them on a scale, they would weigh the same amount. And because they have the same value, we can use a method that says, over in this equation, we can add different things to different sides of the equation as long as they have the same value. So the rule of equality says you can do unto one side of the equation as long as you do the same unto the other side. So on the left-hand side, we're going to add our 5x minus 3y. And on the right-hand side, we have to add something that has equal value, and what we're going to do is add 16. And the reason we're doing this is because we want all of our variable terms to line up so we can do some combining of like terms. So what you'll see as you get further in this, if they aren't arranged in a nice convenient way like these ones were, you're going to have to do a little rearranging first to make sure that your similar like terms line up. And what I mean by that is, take a different color. We have all of our x terms stacked, we have all of our y terms stacked, and then we have all of our constant terms stacked. And now we just do the addition. If you add 2x plus 5x, you get 7x. And this was set up nicely so that if we add 3y and negative 3y, they cancel each other out. So these go away, and that's the whole point. All of these methods are trying to go from two equations with two variables down to one equation with one variable. And on the other side, we have 14. So therefore, x equals 2. You can put 2 back into either equation. So showing the first one. So we get y equals negative 2. So there will be our solution, 2 comma negative 2. So again, this is the simplest version when they are already lined up with the like terms in the same order, and also so that the coefficient, the 3 and the negative 3, would nicely cancel each other out. As we get to more complicated versions, we're going to have to do a little bit of manipulation, rearranging, to make it so that the equations are ordered in the same way, and so that there'll be coefficients that will cancel each other out. But for now, this is sufficient to get you to understanding what the elimination method does.